Hey guys, my name is Shreyas and welcome to Simple Chemistry. Today we're going to be talking about how we name bases. So what is a base? A base is ammonium or metal plus the hydroxide ion. And the way we name them is pretty simple. We name them just like ternary salts. We write the name of the metal, we write hydroxide, and we use Roman numerals for transition metals. This should be very easy. So as you can see here, in our examples here, everything ends in hydroxide. So basically a base is just a ternary, it's kind of like a ternary salt where the polyatomic ion is hydroxide. So let's go ahead and name these. We have magnesium here. Now magnesium is not in this group right here. It's not in this section of the periodic table. It's in this row. So that means magnesium, you're not going to have to use the Roman numerals. So we just write magnesium. You just write magnesium, write the name of the metal, and then we write the word hydroxide. Fairly simple. Now here, nickel is not in these two columns of the periodic table, and it's not one of these elements. It's not silver, cadmium, or zinc, or aluminum. So we're going to have to, zinc is actually, wait, let me see. Nickel, sorry, what I was saying. So nickel is actually right here. So we're going to actually have to use our Roman numerals to specify the oxidation state of this nickel when we name it. So the way we find out the oxidation state, let me write this a little bigger here. Hydroxide has a -1 charge, okay, and since there's 3 hydroxides, the overall negative charge is -3. To balance that out, we're going to need to have a +3 charge. Since there's only one nickel, +3 divided by 1 is just +3. So that means the nickel has an oxidation state of +3. So when we write our the name right here, we're going to have to write nickel, not nickel, hold up. Nickel, and we're going to have to write the Roman numeral to indicate the oxidation state. So since it's +3, we're going to have to write the Roman numeral 3 like this, and then just hydroxide. All right. So this is just like naming ternary salts, basically, except it just ends in hydroxide. Very simple. Now let's work backwards here. We have ammonium hydroxide. So ammonium is NH4+. So it has a +1 charge, and we have hydroxide, OH, which has a -1 charge. And since they balance out, ammonium hydroxide is just NH4OH. Those +1, -1 balances out. Same thing happens here. Sodium is Na, hydroxide is OH, and we know that sodium has a +1 charge because it's in this row of this column of the periodic table right here. And the way I know that is from oxidation states. If you don't know what oxidation states are, go ahead and watch that video. It's either called oxidation states or oxidation numbers. Go ahead and review that lesson before watching this video. So we know sodium has a +1 charge, and hydroxide has a -1 charge. So they just balance out. So sodium hydroxide is NaOH. Now here we have tin 4 hydroxide. So we're going to have tin, which is Sn. And we know it has a +4 charge because of the Roman numeral. And then we have hydroxide, which is -1. And since these charges are not balanced, we're going to have to flip here. So the 1 goes here. So tin is just going to have 1. We're not going to write that down because whenever we have 1, we don't write it down. And the 4 goes here. So there's actually 4 hydroxides. So tin 4 hydroxide is SnO4, OH 4. And that's basically it. Bases, just like ternary salts, naming bases are as simple as that.